Good morning, good afternoon, or good evening from wherever you are. This is a University of Liverpool Online live webinar. Here at Liverpool Online, we come across a lot of inspirational stories. We come across a lot of students and graduates that have done amazing research, and it's really worth telling their stories. And one such story is about one of our own Masters in Computer Science students, Nida, who has been studying a way to use artificial intelligence and AI algorithms to predict cancer. It's really, really inspiring and it's really motivational. And within the next half hour, we're going to sit down with Nida and find out more about her motivation, her process, and her journey. And of course, what's going to happen next to this wonderful research. This is a live webinar. In case you have questions for Nida, and in case you have any other curiosities that you want to ask, please make sure to put your questions down in the Q&A box. And if we have time towards the end of the session, we're going to also ask Nida a couple of live questions on your behalf. With this being said, let's just dive right into it. And I want to give a warm welcome to Nida. Hi, Nida. How are you?
Thank you. Hi.
Nida,
Hi,
can you tell our audience a bit about yourself and give us a bit of insight on your story?
Thank you. I am from Canada. I've had 13 to 14 years experience in IT. I was working in Procter & Gamble. That's basically what I was doing before this degree. And I've had work experience primarily building global data solutions. And stemming from that, design all sorts of various data-related roles, data architect, data engineer, working on global warehouses, data warehouses, that is. And I had to leave that job due to a personal move to Qatar. Doha, Qatar, that's where I'm calling from right now. And that led to the realization that maybe I could pursue an academic career. And University of Liverpool, this online degree was a great opportunity. Not only the flexibility that it afforded me to do this work online from home, but also just the fact that it enabled me to sort of grow on that data related platform, and through this big data analytics program that I enrolled in, I took that up, and it also taught me concepts of machine learning. And we'll talk about what machine learning is, but basically it helped me build this predictive analytics application which helps predict recurrence in cancer. So it was this skill set that equipped me with the necessary knowledge to to lead me to the point where I'm talking to you right now. On the personal front, while this was going on, this transition that took place in my life, my younger sister had unfortunately, two bouts of breast cancer within a span of 3 years. And both times she was diagnosed with a subtype that we will also talk about called triple negative breast cancer. It's a specific kind of breast cancer. And she had a recurrence. And the second time around when she got it, the doctors were stumped as to how come after extensive treatment the last time with chemotherapy and radiation, this recurrence took place, and they weren't able to offer an explanation. And they found the disease kind of rare, in her case, especially an anomalous case. And that led me, while in the duration of this program, to realize that, as a family, I wanted some answers to understand more about the pathology of this disease, and see if I could get some answers for her, so we can avoid this happening again and take the necessary precautionary measures and preventive treatment. I decided to apply machine learning and basically the knowledge from this degree towards that. And that's why the application was built. In order to build it, I needed the necessary resources. And that's where Microsoft Azure scholarship came in. which is primarily for grad students undertaking research. I'll talk a bit about that as well, but basically that enabled me or provided me the necessary cloud resources, storage, and machine learning tools to be able to build this application. So yeah, that's a little bit about me and yes, in a nutshell.
In a nutshell, it's quite an inspirational nutshell right there. Thank you so much, Nida. And thank you for taking the time to tell your story, because it is important for us to share these kinds of stories. And computer science, data analytics person, goes into cancer research, uses a grant from Microsoft to actually predict breast cancer. It's really, really incredible. But we have a very diverse audience here today with us who are listening and who are, very, very interested in your story. But let's also make sure that they understand how you actually went about doing this. So can you give us a bit of insight about what machine learning is and how it works?
Right. So machine learning is a subset of AI, and artificial intelligence. AI is, of course, a much broader term that cuts into multiple disciplines, not just computer science. It goes beyond that. And it's essentially AI is about, smart machines that can learn and evolve, and based on human-computer interaction and interfacing. And machine learning happens to be the subset of it that applies statistical techniques and methods through algorithms on data to be able to derive these insights. So consider it that if there is an intelligent agent or robot, an artificial intelligence application, machine learning would be the analytical engine behind it. That makes it smart. So that's essentially what machine learning is about, and it's become extremely popular and diverse in its applications across the board, be it for self-driving cars or robotics or drones, or even in the case of life sciences that we're talking about now, it can be used to classify, for example, based on computer vision and image analysis, to tell apart benign tumors from cancerous ones. So there's definitely a whole slew of applications that are available, and even for understanding disease pathologies such as cancer and patterns within them. Yeah.
And can you give us a bit of insight on how you were using machine learning to actually predict the strain of cancer that you wanted to predict in the case that your sister had?
Right. So if it's okay, I would like to start off by telling a bit about triple negative breast cancer itself, just to define it and explain it a bit. Triple negative breast cancer makes up only 15 to 20% of altogether breast cancer cases. And even within that, within triple negative breast cancer, if it's okay, I'll call it TNBC for short. It's a mouthful, right? So within TNBC itself, there's quite a bit of variation and heterogeneity. So there are 6 subtypes that I have come across so far in my literature review within TNBC. So you can very well imagine that it doesn't always respond very well to conventional breast cancer treatments, because it's not the majority of breast cancers, and due to the variation within it, it often requires targeted treatments, which are still lacking considerably. And so a need has arisen to look into that as well, and there's research on that too. In terms of machine learning and how I applied it towards this, I essentially wanted to understand the nature of this disease and the pattern, and what leads and what leads to such an incidence of TNBC, the molecular characterization and nature of it, and besides its makeup, then also understand how someone who's had it twice, someone who's had it come back to them, that they've had a recurrence of the same triple negative breast cancer, how is it that their genetic makeup their genetic expression differs from those who've had it only once. And so basically we analyzed a whole bunch of triple negative breast cancer data sets with real patient profiles, analyzed those who've had a recurrence versus those who've not had a recurrence, and applied machine learning algorithms to that. Because I saw a distinct pattern, a differential pattern for those who had recurrence, I was able to say, okay, if someone is reaching those levels, then that is a risk that this person can actually have recurrence. So that differential expression, genetic expression, allowed me to apply these algorithms and be able to predict if someone is at risk and be able to classify that. There were other factors as well besides genetic.
Okay, that's quite an interesting take on it, and it's a forefront between computer science and big data, and also medical research. And I know that as some of our audience members are more technical, and there has been also a question that we've received from the audience previous to actually the webinar starting, and we want to thank for the questions that we've had. So maybe you can tell us a bit about what was the solution architecture and the workflow that you applied, and how did you go about actually making sure that you would come up with the right process and algorithms?
Absolutely. Thank you for bringing that up, and thanks for the question. I can walk through the solution architecture very briefly and maybe try to address this question as well. So the primary source for breast cancer cases, and specifically triple negative breast cancer, the source was the National Center for Biotechnology Information website. It has a multitude of data sets on breast cancer and other cancer and diseases with genetic sequences, DNA, RNA, proteomic data sets, which are associated with actual research and studies. So those studies also help explain the data sets and the underlying data, and other variables as well, such as ethnicity or age of the patient, whose genetic sequence is there. So these were real cases, and basically with these associated studies, I could see that there were certain biomarkers that were called out again and again, certain genes that really stood out that could help identify this disease. And so this enabled me to validate through those data sets if they really stood out. Some of the data analysis was carried out within the NCBI website. It's got great analytical tools. It's got they help you capture things visually. You can have plots on that, and as well as call out significant genes, within a sequence. That analysis and the literature review helped me shortlist certain genes that I saw had a differential genetic expression across the board for TNBC. And this was, of course, only within the realm of NCBI, but then we ventured into the actual cloud resources by Microsoft and Machine Learning Studio, and a great, very user-friendly platform, I have to say, state-of-the-art machine learning tools. And this was important because sometimes you have, I even threw in like hundreds of thousands of rows of genetic sequence at it, just to see how it would work. And sometimes you need that in terms of testing feature selection. Sometimes you want machine learning to be able to pinpoint and say, hey, which features are most predictive. And so that was also validated. There was a second validation of whether I picked the right features or genes or not by looking at it again in Machine Learning Studio, which is that box over there. And of course, I started off with 9 data sets, breast cancer data sets, which had over 2,000 records, including TNBC, but not just TNBC, other types as well. This was important so I could understand and identify TNBC among other breast cancer types. So ultimately, what I ended up using were 4 data sets comprising of approximately 500 TNBC records to train and build the algorithms, the underlying algorithms behind the application. The algorithms helped in identifying TNBC, among other records. They helped in subtyping within TNBC, understanding the different variants of it. And the most important thing, of course, to be able to predict recurrence based on these genes. I also compared them with normal breast cancer samples to be able to see what the normal expression ranges are. That also helps set a benchmark. So this was essentially the process or the thinking behind it. And of course, the algorithms built within Machine Learning Studio also helped me then further finalize the variables. I also incorporated some non-genetic variables like reproductive factors, BMI, which is body mass index, also some existing breast cancer mutations that are always looked at when a breast cancer patient comes into diagnosis. So BRCA mutation, TP53 mutation, these were also added to see if we understood underlying conditions or pre-existing conditions and mutations. This final variable list, of course, then led to the, I apologize for my hand going led to the eventual algorithm, the two algorithms that helped determine root cause as well as predict recurrence. And this was incorporated in a web interface, so an application.
And what is the success of these algorithms?
Oh yes, thanks for bringing that up. that's very valuable.
That's very important. Yes.
We evaluated the machine learning models. When I ended up with an accuracy of more than 90%, I thought that was a good point to stop, because this is not primarily classification where we're saying, hey, is this a tumor or not? This is predicting the future. So there are a lot of unknowns with it, but I thought 90% was a good solid threshold for being able to make this classification. This was then to know whether this 90% was really truly 90% or not. I basically tested it with certain TNBC cases. So I had test cases where I used those that had not been used to train the algorithm. So I kept them apart from before, and I essentially added their values and their genetic expression to see if someone had a local recurrence, would it be able to predict them as high risk or not? And so that was basically the measure of it. And 90%, yes, we attained the 90%, and it was able to successfully predict local recurrence for such cases without knowing whether these were new cases entered. So this was, and also be able to tell the root cause behind why that incidence could have taken place.
That's very fascinating. Just on a side note, what would this mean for your sister, for example? What would this kind of research mean for your sister?
Thank you so much for bringing that up. Otherwise, I may have forgotten it. There were some key takeaways from this, which may otherwise be missed in if you're just looking at breast cancer in general, because there are some things that stand out specifically for TNBC pathology. One of the things that stood out was reproductive factors, pregnancy, which there was a big study that came out last year related to whether pregnancy contributes to recurrence risk, whether it increases risk of recurrence for breast cancer. And essentially it said, no, it doesn't, because those cancers were primarily not triple negative. That study was for estrogen positive cancers and not triple negative cancers. So triple negative, on the other hand, there is extensive study done on this in terms of whether it increases risk, pregnancy increases recurrence risk or not if you've already had TNBC before. And yes, it does. Short term, yes, it does. During pregnancy and within 1 year postpartum, there is increased short-term risk due to pregnancy, due to the genetic changes within the breast that could lead to risk for breast cancer. However, pregnancy is known to have a beneficial effect long term, especially post-menopause. So while it does have that benefit long term, it does introduce a short-term risk specific to TNBC. And that's why TNBC is very highly associated with pregnancy-associated breast cancer and a higher recurrence rate if you get pregnant after having had TNBC before. That was one key takeaway. A second one was about weight. BMI, body mass index, has been associated, high BMI has been associated in quite a few studies with breast cancer risk. However, in the case of TNBC, this is what I found out. While there is that risk of a first-time incidence with TNBC as well, just like it is with breast cancer overall, in terms of recurrence, there wasn't a significant correlation. If you've had it before, TNBC before, there's an equal chance, whether low BMI, high BMI, which weight class you belong to, there's an equal likelihood of a very similar recurrence rate observed for that. So BMI is not a big significant factor for recurrence. The third one is, of course, about the differential genetic expression that we mentioned, which is certain genes that are able to highlight and say, tell with certain predictive accuracy that, if you have a higher expression, for example, for certain cell proliferating genes that promote tumors, you are at a higher chance of recurrence, and they're higher than those who've had it only once. And the same thing goes with those that are tumor suppressor genes, in which you would see a lower expression in those that have a higher chance of recurrence than those who've had it only once. So these were the key takeaways: the genetic expressions, pregnancy risk, short-term only, and BMI.
That's fascinating, and you sound like a doctor, and yet you come from a science background. So it's fascinating how data and big data can actually help us understand better, all facets of life and society. Thank you for sharing that. That's really, really amazing. And of course, we cannot actually, imagine that you could have done this, just using a computer. There has been an entire AI system behind. And for you, as I understand, you could have access to such an AI through your Microsoft Azure scholarship. So can you give us a bit of insight on how that happened and what did that imply for your research?
Absolutely. Thank you. This is important, especially for those who have self-initiated, self-led projects like I had without a business sponsor, and therefore they need such resources to be able to implement their applications and to be able to build their solutions. Microsoft, the scholarship, these are offered by other cloud providers as well. I wanted to go with Microsoft. They offer wonderful scholarship opportunities. That is, the grant is essentially cloud resources. In my case, it was unlimited cloud resources for a year, or up to $20,000, which, believe me, I haven't run out of. I've got plenty of it still left. So when we say 20,000, it's quite a bit, and this is for massive mining, massive data sets of terabytes worth of data, and thousands of rows and hundreds of thousands of features and variables to look at. So that is one. And what enabled this to happen was essentially this program of University of Liverpool, because only those who are coming from such a university as this one and this platform that I got, first and foremost, to build a skill set of machine learning, and then I qualified because I was enrolled in this MS program and trying to undertake this research. So that qualified me to apply for this. I pitched in my proposal and they liked it, and they went ahead and granted me the scholarship. So I was lucky that I got the chance to be able to work with the right tools, work with great faculty, a wonderful platform of University of Liverpool, and the support that I got from all you guys. So as far as this is concerned, I would say, and I would recommend for anyone who's initiating it themselves, who don't have the resources, please go ahead. If you're undertaking research, backed by University of Liverpool, you'll get in. So go for it. And if it's a meaningful proposal that contributes, to the larger community, I'm sure it would receive the attention that it deserves. So
brilliant. And you know what other better way to put an AI to use than to predict cancer? So really, really
yes,
fabulous to hear.
thank you.
But this is not, the end of the dissertation, the research story. And we've had a conversation before where you were actually mentioning what you want to do next. So what's the next step you want to take? What's the next journey?
Yes, I think that will sort of help bring full circle what I meant by the platform and how it's propelling things forward. So not only did this did the combined resource, that the fact that I had the scholarship from Microsoft and this degree program, not only did it benefit me in the duration of this program and with this project, but it also enabled me to sort of continue this my research. I am now enrolled for a PhD program. I have I just received the news. I'm extremely excited about that. So I will get. I'm lucky. Thank you. I'll get to continue this research and extend it to other areas that I wanted to take it to. And similarly, I'll also apply to Microsoft again to extend my scholarship with them as well. And based on these research interests that I will now have. So I'm excited about that opportunity, and the reason I'm looking into so far I was only looking at local recurrence. Local recurrence essentially means that the cancer comes back in the breast or in the same organ. Now I'm looking into distant metastasis, which is that it travels to other organs such as brain, lung, or liver somewhere else. And that's going to be my area of research interests essentially for TNBC. This is what I'm going to continue with PhD, and I'm going to I'm now totally AI data driven, so I'm much more prepared to undergo that journey. So I'm excited.
That's
thanks.
wonderful to hear, and we wish you the best of luck also with your next steps. And I think it's important what work that you do, and it's inspirational. And maybe one day we'll be talking to a Nobel Prize winner in science. So I can't wait to see where this goes. But before we close off, because we are running close to the half-hour mark, we just want to ask you one last question. What would you recommend anyone who wants to take up a degree here with the University of Liverpool online? What would be an advice that you would give them?
I would say maximize the resources that are given to you. It's a wonderful platform. The exposure, for example, this application has gotten. So thank you so much. So many people watching. I really appreciate it. And this is just to build that awareness, that this goes forward and other people take an interest. I would say go with the project that you are very motivated and you're very passionate about. Maximize the library, a wonderful resource for research. The faculty is very helpful and supportive. Then, of course, there are these other cloud resources. I would say, especially for those in computing programs, to definitely look into and pursue for their research. So I would say look across, but more than anything else, be passionate about what you do, because sometimes you're staring at it for hours, and it should be something that truly drives you and you think about all the time. So sort of becomes an obsession. But it's all good. It's all good. So yes, just something that really drives you and motivates you is what I would suggest. And the University of Liverpool, the programs, they're great. They're great. They're wonderful. So it definitely something I strongly recommend for others to take on.
Thank you so much, Nida. There you have it, a really wonderful story about how to use big data and computer science and artificial intelligence into predicting cancer. And why not? We live in such a world where technology is a good solution for a lot of the world's problems. Thank you, Nida, for being here with us.
Thank
Thank you
you.
for telling your story. It's a very inspirational story. I hope our audience also enjoyed it as much as I did. And I hope that we will see you do great work. Have a good evening ahead. Thank you for showing up. This has been a University of Liverpool online live webinar, and I wish you all the best of luck with anything that you are actually pursuing. Bye, Nida.
Thank you for the opportunity. Thank you. Bye.